All right, let's cut right to it. Forget the military parades. Forget the glossy marketing brochures. What I'm about to show you is based on what we're actually seeing on the battlefield. Reports and intelligence that tell a very different story. We're going to break down this growing gap between how China's military hardware is supposed to perform and how it's actually performing when the shooting starts. So this is the central mystery, right? You see these advanced-looking Chinese weapons, missiles, radars, entire air defense networks showing up in real-world conflicts. And frankly, they're underperforming in ways that should make anyone relying on them for national security very, very nervous. Today, we're going to get into exactly why that's happening. You know, the investment here is massive, no question. The technology looks sophisticated, it looks modern, but when the pressure's on, the battlefield data is telling us a stark story. The results are just falling short. And this isn't about a few minor glitches. We're seeing a pattern emerge. Okay, so we've established this pattern of failure. To really understand it, we've got to look at this battlefield anomaly itself, this huge gap between how these weapons look rolling down a street in a parade versus how they hold up in the messy, chaotic reality of actual combat. And look, this gap between perception and reality, it isn't just a theory. We've got real-world case files. Let's dig into two key hotspots, Venezuela and Iran. These are places where these systems were put to the test, and they failed, exposing some pretty critical vulnerabilities. The intelligence coming from the field is crystal clear. When these systems go up against sophisticated electronic warfare, things like jamming and spoofing that are designed to blind a radar, they just crumble. In Venezuela, we saw repeated radar lock failures. In Iran, the system couldn't even put together a coherent picture of the airspace when it was being probed. The promised capability, it just wasn't there. And that really brings us to the key question, doesn't it? Are we just looking at some simple engineering flaws, stuff that can be patched with a software update? Or are we seeing evidence of something much deeper, something more systemic and fundamental to how China develops its defense technology in the first place? Well, all the evidence points to something much more fundamental. It really starts with their whole development philosophy. Look, they are masters of copying technology, but that strategy has a hidden and, frankly, a potentially fatal flaw. It's this problem of the blueprint versus the brain. Just take a look at this. On the surface, the copies are almost indistinguishable from the originals. The Chinese J-11 fighter, it's a dead ringer for the Russian Su-27. Their HQ-9 air defense system looks just like the Russian S-300. But as we're now seeing on the battlefield, looks can be incredibly deceiving. This right here gets to the absolute heart of the issue. It's a core principle that every single defense engineer understands. You can copy the physical design, the blueprint, but what you can't copy is the decades of knowledge, the brain, that made that blueprint work in the first place. So what is this brain? Well, it's all the stuff you can't see. It's knowing why a specific metal alloy becomes brittle under the stress of hypersonic speeds. It's understanding the exact failure point of a guidance chip at 40 below zero. This is knowledge born from thousands of trials and errors, stuff that lives in old notebooks and in the collective memory of generations of engineers. You can't steal that. But the problem actually goes even deeper than just recent reverse engineering. We have to look at the human factor, the institutional issues. Because let me tell you, a flaw in the system's integrity can be just as deadly as a flaw in its design. Okay, so in 2023, something truly extraordinary happened in Beijing. The entire leadership of the PLA rocket force, we're talking about the custodians of China's nuclear and conventional missiles, was abruptly purged, fired. This wasn't just a routine shuffle, this was a sign of a very, very deep crisis. And the reason for this purge was absolutely stunning. Intelligence reports revealed corruption so profound, so deep, that it threatened the nation's entire strategic deterrent. We are talking about allegations of contractors filling missile fuel tanks with water instead of propellant. This is so far beyond just skimming a little money off the top. So here's the crucial takeaway. If China's most elite, most heavily scrutinized military branch had missiles that literally might not launch, what does that tell you about the reliability of the thousands of parts in a radar system sold for export? This isn't a quality control issue. This points to systemic rot. So, let's put this all together. You have a copy that's missing the brain, and a system that's potentially riddled with faulty components due to corruption. This creates what we in the industry call the Inventors advantage, a permanent strategic edge for the original designers that turns the gap between the original and the copy into a massive tactical chasm. This is a core concept for us. See, when a country designs a weapon, they spend years and millions of dollars testing it to failure. They know its weaknesses intimately. They know exactly which radio frequencies will confuse its seeker. They know which flight patterns will defeat its guidance. The creator always knows the back doors. And that knowledge gives adversaries a tactical playbook. When US or Israeli forces encounter a Chinese-made radar that's a copy of a Russian system, they aren't just facing some new piece of hardware. They're often facing a system whose fundamental design flaws they already understand because they've studied the original for years. This analogy just captures it perfectly. It's a totally asymmetric advantage. The adversary is basically operating with insider knowledge against a user who might not even be aware that their multi-million-dollar system has these built-in inherent vulnerabilities. So this toxic combination of flawed copies and systemic corruption creates a huge problem, not just for China, but for the dozens of countries that are buying its weapons. And this is what we call the arms export trap. Think about it. Countries from Pakistan to Venezuela, they're walking right into this strategic trap. They're betting their national defense on systems that are unproven, whose fatal flaws might be well known to their enemies, and which they have absolutely no deep knowledge to fix or adapt when things inevitably go wrong in a real conflict. And here is the bottom line, the crucial point to understand. In modern warfare, it's the knowledge that's the decisive weapon. The hardware is just a tool. It's the deep understanding of how and why it works, and how to fix it when it breaks under fire that provides true combat power. Ultimately, this entire issue really just boils down to this one fundamental truth. The next major conflict isn't just going to be a test of hardware. It's going to be a test of whether copying a technology is really the same as mastering it. And based on the evidence we're seeing, the answer is becoming pretty clear. And all of this analysis leaves us with one final critical question. As this hardware continues to spread across the globe, figuring out the answer to this is absolutely essential for global security. It is a hidden flaw that could have some very, very public consequences.